All right, let's dive into a really wild thought experiment. I mean, on the plus side, you'd finally get an off switch for daylight, but on the downside, you'd be messing with the laws of physics in a big, big way.
So, here's the scenario. What if we just replaced the sun? Like, swapped it out for a giant LED light bulb. Sounds simple, right? Well, turns out the consequences are, let's say, universe-altering.
Okay, so to really get this, you have to understand the massive difference in scale we're talking about. The sun, it's a colossal nuclear reactor, a raging furnace turning millions of tons of matter into pure energy every single second. An LED? Well, it's just a little semiconductor. It's kind of like trying to replace an active volcano with, I don't know, a scented candle, and then expecting it to heat the whole planet. Yeah, not gonna work.
So first question, how much power would this thing even need just to match the sun's brightness? And this is where the numbers start to get, well, literally astronomical. The number is 174 petawatts. Now, what does that even mean? To put it into perspective, that's like taking all the power the entire human race uses and multiplying that by almost 9,000 times. There is no power grid for that. You're not going to find an extension cord long enough, I can tell you that.
Let's try to wrap our heads around this a bit more. We're talking about a power demand that's thousands of times bigger than our entire planet's energy use. Or think of it this way. It's like setting off a Hiroshima-sized bomb every single second, forever, just to keep the lights on. That's the mind-boggling scale we're talking about here.
But okay, let's just wave a magic wand. Let's pretend we solve that little power problem. We flip the switch, our giant LED lights up, it's just as bright as the sun. Everything's fine, right? Our new solar system is good to go, right?
Yeah, not so fast. This is where we hit our first huge problem. Because even with all that brilliant light, things on Earth are about to get fatally cold. So you're probably thinking, but wait, it's just as bright. What's the problem? Well, thinking that would be a deadly mistake. See, the light our eyes can see is only a tiny part of the story. We're missing the other kind of energy, the invisible stuff that actually keeps us from freezing to death. And this really gets to the heart of it. A huge chunk of the sun's energy, more than half actually, is infrared radiation. That's just a fancy way of saying heat. It's the warmth you feel on your skin. But our super efficient LED, it's designed to turn almost all of its power into visible light. So you get all the brightness but almost none of the warmth. And without that warmth, well, the fallout would be fast and it would be catastrophic. Within just a few days, global temperatures would plummet. Photosynthesis grinds to a halt. In a matter of months, the oceans start freezing from the top down. And after just 1 year, our beautifully lit planet would be nothing but a giant global snowball.
So, a new ice age. That's pretty bad. But believe it or not, there's an even bigger problem waiting for us. Because it turns out the sun does a lot more than just give us light and heat. It's also the only thing stopping us from being flung out into the empty void of space.
See, our giant LED, no matter how big or bright we make it, has practically zero mass. And mass is what creates gravity. The sun's incredible, unimaginable mass is the gravitational anchor holding our whole solar system together. It's what keeps us all in this beautiful cosmic dance. You take that anchor away, the dance is over.
The moment that gravity vanishes, Earth stops orbiting. Instantly, it just flies off in a straight line, continuing at its orbital speed, which is a blistering 30 kilometers per second. We'd become a rogue planet, an interstellar runaway, just a frozen rock hurtling through the infinite darkness forever.
But let's keep playing pretend. Let's say we somehow solve the impossible power problem, the freezing to death problem, and the flying off into space problem. There's still one final fatal flaw. Our brilliant solution has a built-in expiration date.
And here it is, the ultimate deal breaker: lifespan. The sun, it's good for about 10 billion years. Our amazing, super advanced, universe-sized LED, you'd get about 50,000 hours out of it. That's roughly 6 years. It's just a cosmic blink of an eye before the lights go out. For good.
So after just 6 short years of lighting up our frozen, runaway planet, the universe's most expensive light bulb would just flicker and die. And spoiler alert, the universe doesn't have a good return policy for faulty galaxy-sized electronics. So after all that, what's the point? What's the big takeaway from this beautifully illuminated apocalypse? What does this whole thought experiment really tell us about our own sun?
Well, it shows us that the sun is so much more than just a big light bulb in the sky. It's our gravitational anchor. It's our thermal engine. It's the life-giving heart of the entire solar system.
It's this incredibly complex system that we depend on for literally everything. And that's really the final lesson here. A star isn't a lamp, and a lamp could never be a star. When you try to swap one for the other, it doesn't just fail a little bit. It fails on every single level you can imagine. All you're left with is a beautifully lit but ultimately cold, dead, and empty tomb.